So today is the last of the scale drawing lessons that we're going to be doing. We're going to review tomorrow and either tomorrow or probably Thursday, Wednesday, better be comes after tomorrow. You will be taking your Unit 2 assessment. It's really not that big a deal. Just sit down and draw and we'll find it when the lesson is over. All right. So, looking at our warm-up for today, it says, what is a scale drawing? So here are some drawings of a school bus, a quarter, and the subway lines around Boston, Massachusetts. The first three drawings are scale drawings of these objects. Obviously, because why? Put your pencils down. Why are these scale drawings of a school bus, a quarter, and the subway map? Why are they a scale drawing of those? Alexa?
Because they're not student original copy.
Right, because if we were looking at a original copy of a school bus, it would fill the entire room, right?
Yeah.
Or a quarter is actually going to be a little bit bigger than that one. Or the subway map is going to be very large. So yes, these are all scale drawings. Now, the next three are not scale drawings of these objects. So still school bus, still quarter, still a subway map. So what you have to do is discuss with your partners what a scale drawing is. All right, so you're going to get 1 minute to just have a conversation with the people at your table, come up with a really good definition, and then if you finish within that 1 minute, go ahead, write it down. If you don't, you'll get about 30 seconds to write what you guys come up with. Okay? Go ahead.
Copy is basically like something that's simply bigger, like smaller than the original. And if you look at the non-scale drawing, you can tell that the scale is big.
It has to be basically that exact okay, we get it. Okay, so the next big drawing. Okay, so that's the scale drawing, and then these are not. Easily sorted. Look at the George Washington. And the school looks like the school bus looks like a color.
All right, take 30 seconds and get your answer written. You're not talking anymore. Jack, stop. All right, so let's go ahead and, what did you guys come up with your answer to what is a scale drawing? Cooper,
We wrote that scale drawings or drawings where the lengths are factors of like the original drawing.
okay, so scale drawings are drawings where lengths are factors,
Yeah. Where it is
or what?
or like divisors
Factors, divisors.
Yes.
Of what?
Of the original lengths.
All right, who else wants to add? What else did you guys come up with? Jack?
Just doing what Cooper said, but they're not the story.
So drawings that aren't distorted. All right, what else? What else do we want to add? I'd really appreciate it if y'all were not looking at him and you were actually looking up here and paying attention. I'd appreciate that, like a great deal. Hunter.
It's a bigger, smaller copy of the original object, but not stretched or distorted.
Okay. So bigger slash smaller copy, you said?
Yes.
Copy of original, but not stretched.
Stretched or distorted.
Alright, those are all really good. Alright, so now let's slide over to the next activity. So your next activity is, you're going to be working with a partner in a second, not right now. So I'm going to give you a picture of a basketball court. This is the picture that you and your partner are going to get. Okay? It says the drawing does not have any measurements labeled. So as you know, there's no measurements labeled. But it says that 1 centimeter represents 2 meters. Okay? Did it just give you a scale factor? Just making sure we all understand. So it says measure the distance on the scale drawing that are labeled A to D, which you'll see once you get this, to the nearest tenth of a centimeter. Record your results in the first row of the table. So you're going to record your scale drawing in the first row. Statement 2, or number 2 says the statement 1 centimeter represents 2 meters is the scale of the drawing. It can also be expressed as 1 centimeter to 2 meters, or 1 centimeter for every 2 meters. What do you think the scale tells us? So you and your partner have to answer that question. Number 3 says, how long would each measurement from the first question be on an actual basketball court? Explain or show your reasoning. And then number 4, you have 2. It says on an actual basketball court, the bench area is typically 9 meters long. Without measuring, determine how long the bench area would be on the scale drawing, and then check your answer by measuring the bench area on the scale drawing. Did your predictions match your measurement? Okay? You are getting 15 minutes to do this with your partner. It's not like you got 5 minutes or 6 minutes or 7 minutes. But in those 15 minutes, we're going to come back together and you are going to provide me with answers, because there are right and wrong answers here. It's not like, oh, well, I think so, or no, like right and wrong answers. You need to produce answers, not sit there and play and braid each other's hair and whatever. I don't even know what y'all do. Like, the things that happen when you work in partners scares me. So, yeah. I don't care if you work around the room. I don't care if you table, it does not bother me. What I need you to do at this point is get with your partner and then send one of you to come get your paper and your ruler.
Here's the bad thing about rambling.
Why are you touching your ruler?
They distract me.
We can't even follow directions!
You distracted me.
Chill!
I'm tired or what?
You look bad. You have bad today.
Oh my god, that's so embarrassing. I know. Okay, no one I got no sleep. I'm tired.
Get in a line! Everybody else should be sitting quietly.
Which one? Oh, yeah, we don't. I don't really know.
Sit. Sit. Not in front of the camera.
You got a clipboard to write.
Okay, so wait a minute. So one second.
And you can do whatever you want.
So we would write the measurements.
Imagine this. Your first wish was to make you bones. Now you make snowy. And they write their names. You're Jay.
Jason, so I just wrote the measurement between A and D is 3 centimeters.
give me. I didn't know that.
The measurements are basically
You guys are wasting all your time back there. There are 10 millimeters and 1 centimeter. Go from there.
Is the skill what do you think is skill? It tells us the skeleton copy of the original. Because it would tell you one it'll basically tell you like the skeleton copy for the court.
Miss Kitty, can we write on the paper?
Oh wait. My bad. No wonder we got to know your number.
Miss Kitty.
Right. First off, I saw your classmates here talking about there are 10 millimeters.
So it's not saying that's like
You would know. That's saying that like if it's 1 millimeter and then half 1 millimeter. Like that's 10
So you're trying to write. So wait, no, that's 22. Yes.
Okay. It tells us the scaled copy of the scaled copy.
So what does 1 centimeter, 2 meters represent? Also, what is it? I legit already used the expression when I was
Smaller than
like, I already used it. It's already
100 by 100.
Okay.
So number 3, how long does the measurement of the first question beyond the actual measurement?
A would be your mom versus
Oh wait,
Okay.
What is that?
And this is like 1 meter for every 2 centimeters. 1 centimeter for every 2 meters.
why is your mom?
I use the grammar.
Okay, so wait, so 103, it says how long would each measurement from the first question be on the actual basketball? So from A to D is 3 centimeters, so that means it would be 6 meters. So that means, wait, sing of the actual court.
Yeah.
So 30 centimeters. It would be oh, the measurement, the length. What would be the length? Like A to like the measurement. A to D. Oh, what were you
Yeah, I asked him that I should.
Wait, the width of the court. So the width would be like right here. So what would be the measurement?
No, I'm pretty sure with. Wait. No, with the court would be. So.
Okay, so what would be the
Almost at half.
Okay.
Almost 3.5.
So what would be right? 3.5? What? 3.5? We're not checking right now.
No, I can't.
No.
Wait, measured it again. Yeah, 3.5.
Guys have 6 minutes left.
Yeah. Wait, so this would be 3.5, so it'd be 3.5? 3.5 and then 7.
I lost it.
Oh no, you're right. It would be
No, I lost. No, what I'm saying is I lost my.
Oh yeah, because if you get
okay. The hoop to hoop. What would be the measurement?
Okay, so.
But since it says every centimeter is meters, we'll just count this.
Wait, no, those are centimeters. I can go
Hoop to hoop would be So that means we have to remeasure. Look, now we have to remeasure it because you didn't want to.
I use this.
Yeah. So that means it would be 3. Yeah, you're right. It would be 3.
No, bro. This is the right one.
Yeah. So it would be 7.5. Look.
Yeah, we skipped it. Because he was these are the best.
What would be the
I think it means
Like you're measuring A, B, C.
all eight. Not eight. I didn't think about
Y'all
that.
are so smart.
Yeah, definitely.
Okay, what would be the measurement for this? What is this?
Once you're done, go back to your knee. You guys have 2 minutes.
Oh, we already did it. Oh. We just realized we did it. Yeah, we
Figuring out.
We finished. Oh, wait, we gotta get
Joseph, come get your junk out of my system, please.
Yes, junk.
Hey, go with you, because we're in it.
Bro, you're getting it wrong.
You smell like roller into that.
It sounds like one of those.
Okay, what would be the
Hunter, the only thing you should be doing on the iPad right now is Imagine Math. If you're doing anything other than Imagine Math, you can just bring me the iPad.
What is the sequence?
Yeah, it's 3.9.
I'm a loss.
No, that no, the real line is right here. That little hop with the line. Okay, so that means
I should be using 3, please. So what would it be?
no, it's 3.9 beside one. That means it'll be 1 centimeter to 2 meters.
All of that information should go.
So it would be 1 centimeter.
Put it in the first row of your chart.
So let's go down here. 1 centimeter, Actual basketball for the bench area and I need not measuring for how long this
Guys have 30 seconds. Head back to your seats, please.
You're the last one.
Watch the iPad. Head back to your seats, y'all. There, right, Jason?
Yeah,
We're in the last one.
yeah. We're on the last one.
Alright, get there quickly, quietly. iPad should be closed. Get off of your iPad. Alright, so number 1 said and measure the distance on the scale drawing that are labeled A through D to the nearest tenth of the centimeter. Record your results in the first row of the table. So I know that this was somewhat difficult because our rulers did not have centimeters, so I do apologize. And they smelled really bad. I do apologize. But what was the roundabout length that you guys got for A, which is the length of the court? So from one end to the other end. Nisha, what did you guys come up with?
14.
Yes. Well, we're just going to try to keep it as nice numbers as possible. So 14 centimeters is what you should have, or close to 14 centimeters. If you are like super far off, then you need to change it. If you're like within a couple tenths or whatever, that's fine. You can just leave it. Does that make sense? All right. What about the width of the court? What did we come up for the width? Jackson.
I got 7.5.
Yes. All right. What measurement did you get from the hoop to the hoop? Cooper.
12.5 centimeters.
Okay. All right, and then from the 3-point line to the sideline, what did you guys come up with for that one? Cooper.
Me? 11.
Just 11? 11 what?
Oh, 11 centimeters.
No. Not even close. Hunter.
0.5.
Yes.
Yeah.
All right, so you should be about those numbers. Not exactly, but very close to those numbers. Okay? All right, so number 2 then says the statement, 1 centimeter represents 2 meters is the scale of the drawing. It can also be expressed as 1 centimeter to 2 meters or 1 centimeter for every 2 meters. What do you think the scale tells us? So what did you guys come up with this one? Raheem, what did you guys come up with?
Listen, the scale tells us that for every centimeter we measure is equal to 2 meters. So we would multiply by 2 to get the number of meters.
Okay, so I'm going to steal the first part, so say it again for me.
The scale tells us that for every centimeter we measure is equal to 2 meters.
For every 1 centimeter, at what?
We measure is equal to 2 meters.
All right. I have a question. Did anybody look at this as a ratio? Because that's exactly what it is, isn't it?
Yeah.
Especially this one right here. The 1 centimeter to 2 meters, or 1 centimeter for every 2 meters. Again, remember when we first started this, I said it's very much like equivalent ratios. That's what a scale, drawing scale, factor scale, anything is. All right. Anybody else want to add to the first part? I'm going to come back to the rest of your answer in 1 second, Raheem. Anybody else want to add to the first part that they put down as their group? No? Good? Okay. So number 3 says, how long would each measurement from the first question be on an actual basketball court? So Raheem, read the second sentence from your explanation.
So we would multiply by 2 to get the number of meters.
To get the number? Okay. Sorry, number. So essentially what you're doing with all of these now is you're going to multiply those by 2, but they don't stay centimeters, they become what?
Meters.
Meters. All right, so if we multiply 14 times 2, raise your hand, tell me what do we get? Michaela?
28 meters.
Okay. 7.5 times 2, what do we get? Haley?
15.
Not just 15
15 meters.
meters. All right, 12.5 times 2, Cooper.
25 centimeters.
25 meters. And the last one, half times 2, Gabriel.
1 meter.
1 meter. All right, last question, and I know some of us may have not gotten to this one, and that's fine. All right, it says on an actual basketball court, the bench area is typically 9 meters long. Without measuring, determine how long the bench area should be on the scale drawing. So what did you come up with, Jackson?
4.5.
And what made you say 4.5?
Because since it's already 9 meters and 1 centimeter is equal to 2, that means since it's already in meters, you have to divide it by 2, and you get 4.5.
So essentially, you have to do the opposite. So we multiplied to find the regular big size court, but then here we had to divide and do the opposite to find the small. Okay, cool. All right, flip your paper over. Now, tall structures. You are working as a group for this one. All right, let me see that one. No, your tape measure. Let me see your tape. Let me see your tape measure. Do you guys have a tape measure?
I have to measure.
Do you have a tape measure?
They do that.
Do you guys have a tape measure? You guys have two? All right, wait, so you guys have a tape measure? Yes. Okay, so you are going to be using the tape measure in your group. Maybe designate somebody. Just don't fight over it. And you are going to be answering questions 1, 2, and 3. Okay, as a group. You are getting 15 minutes. Your explanations need to be a little bit better than some of the explanations or lack of explanations. Because we had what I think Jackson, Ace, Christian, and Cooper were like the only ones who were volunteering anything that to like share what they're thinking. All right. So please make sure you use your 15 minutes completely. You don't rush through it. And if you have a ruler at your table, please raise your hand. Go ahead and get started.
About how tall is the ruler or how tall is the actual grade?
One person. What do you think?
I told you.
So it would be less than 1 meter.
Is it? Well, actually, according to my grade, how many
Yeah, it's one.
I measured the centimeters, and then the centimeters.
Are y'all working together?
And then I got 3.5.
Really quiet enough.
Right here it says like it's one, and it's like one, and then your shirt like, but it's like the way you draw it, it's right like down here. It doesn't
It's just simply showing you that this distance is 100 meters. It's not saying it's equal to.
How tall is
It's just simply saying it's 100 meters. That whole thing that's like 100 meters. Why are you being so specific? What is the question asking?
about how tall Oh, I didn't see that word.
It is about 110.
It's 500. My brain just like
How much taller is
Guys, if using the tape measure is too complicated, making it too hard, the key words in your questions, there is one specific keyword that tells you that you don't have to be exact. What word? About. So at that point, if using the tape measure is just too much, put it to the side and use the information on your page.
Okay, so right here, 50, so it'd be 500. And then it is about 300 meters.
yeah, we're already explained out.
It's about what? About how much taller is the birds and how far is the words? Wait, do you measure birds telescope?
I'm not.
Yeah, measure the line segment from the scale to the nearest centimeter.
Oh yeah, don't forget to. Where? What is? We're telling you it's fine. We're telling you it's fine. Yeah, but what about iPhone? That means it's 500. Scale me.
Wait, so the line segment shows 6 shows about 610. Okay. Let's go
Y'all need to get it together over there now.
I still didn't have my iPad. I was gonna add my
That's all of them again. I'm talking about You were right. You were right about French culture.
Yeah, but I still like the deal with
Yeah, I got a weird taste.
Oh yeah.
I already know this. Now write it down.
You guys have 2 minutes.
I thought you guys were talking about, like, I was talking about, like, I don't know, I don't like the boys.
I'm talking about like double.
I'm saying,
Measure the line segment that you We're doing the town. But I'm actually
Yeah.
Measure the scale, measure the line segment. Measure this thingy. Dude, measure this thingy. How many more centimeters?
If you are, alright, the person who has the tape measure, please take it and put it on the back shelf for me. And then we're gonna go ahead and get started on these questions. Stop talking. You've had plenty of time to do that, and based off the conversations I heard, it was not all, excuse me, about the math. Alright, so it says about how tall is the actual Willis Tower. So what did you guys come up with? So this is the Willis Tower. About how tall do we think it is? River.
We thought it was around 600 meters.
Around 600 meters. All right, does anybody else come up with something a little bit different? Cooper, what did you guys come up with?
You said around 500 meters.
All right, so we're gonna say between 500 and 600 meters. So, Brock, what was y'all's reasoning? Like, why did you say it was about 600 meters?
Well, because we measured a little line segment
Do not fold them up, just put them on the back counter like I asked. Thank you.
on the side, and it was about 0.5 centimeters. So we just saw how many meters it was, and did the math. It was 6 meters. Or 3 centimeters. Yeah, which is 6 halves. So it's 600.
Okay, all right. Cooper, what was y'all's strategy?
We also measured the line segment, but we did it in inches, and we got about like 1/4 of an inch in that 0 to 100 meters. So then we just multiplied. So like since the Willis Tower, it was 1 1/4 inches. So there's 5 and 1/4 and 1 1/4. And then times it by 100 or 500. So basically the same thing. We just did it in inches.
Okay, I'm trying to figure out how what both y'all did. I'm not even gonna try.
Yep.
It's a lot of math.
Just wild guess.
Good job. So we're just gonna tie a knot on and be like between 5 and 600. Was there anybody who got like a crazy amount? What did you guys get?
Our group measured 350.
How?
I don't think that's our
We said
What we go.
Christian.
It's like we
Christian. Guys, hush. Well, that's not crazy. I mean like super like either really, really high or really, really low. Alright, so we at least were kind of close. Alright, what about the actual height of the Great Pyramid? So raise your hand and tell me what you guys come up with for that one. Alexa.
About 150.
Okay, and what was your strategy for that?
So we had like the little line thing. We extended the line across, and then did like an estimate and drew it in our brains, and like did like that's like half little point thing is like half of the east one. So
Okay.
brain.
Alright. Anybody have a really weird, crazy one for that one? Alright, let's go ahead and move on. Alright, number 2, it says about how much taller is that big giant building than the Eiffel Tower. Explain or show your reasoning. All right, Jenny.
I said 3 times bigger means I measured and moved it up, and it was about 3 times bigger.
So it's you said 3 times bigger.
Yeah,
Okay. All right. Did anybody else come up with something different?
So we got that the Burj Khalifa was like twice the size of the Eiffel Tower. So like the Eiffel Tower was 400 meters and the Burj Khalifa was 800. So it's 400 meters taller.
Okay. All right. Anybody else come up with something different? Taylor, what'd you guys come up with?
We said it was 600 meters bigger, like
Why?
because we said that the big building was 1,000 meters because it had 5 centimeters and 10 half, so that would equal 1,000 meters. And then we said that the Eiffel Tower was 400 because it was 2 centimeters. And then we just subtracted 1,000 or 400 from 1,000 and got 600.
Okay. All right. So it's about 550 meters tall. For short purposes, the Eiffel Tower is 3 100 segments, and BK is 8.5. 100. Oops, I forgot the measurement. 100 meter segments. There should be meters. All right, so this one, it's a little bit more exact than the other ones, but it's about 550 meters different. And then number 3 says measure the line segment that shows the scale to the nearest tenth of a centimeter. Express the scale of the drawing using numbers and words. All right, so what was the scale? Anybody figure it out? Seven tenths.
Oh, we were close.
7 tenths.
We said 6 tenths.
Of a centimeter.
I said 5.
All right. Okay. All right. Well, nobody volunteers, so I have to wait. But finish the rest of the scale for me now, like the scale factor. So I gave you the measurement in centimeters, so it's 7 tenths to what? 100 meters. All right. What's another way we can write that? Absolutely not. Raise your hand. What's another way we can write this? River.
1,000 meters is equal to 7 centimeters.
Where are you getting 1,007?
I mean, he's not wrong.
I mean, I know what you're saying, but we are looking for the scale factor right now. We're not trying to make it more difficult. So this is the scale factor, 7 tenths to 100 meters. So give me another way to say 7 tenths to 100 meters.
100 meters.
To what?
100 meters is equal to 0.7 centimeters.
So you can do all that crazy math and make it like exactly right, but you can't say my decimal correctly? Did you say 0.7? I know you didn't say 0.7. What is that decimal?
0.7.
Thank you. All right, someone else give me something different. Something different. Still using 7 tenths and 100, but give me some different words in there. Cooper.
Oh, okay. For every like 7 or 7 tenths of a centimeter, it's 100 meters. That's what I was
For every 7 tenths. All right. If you did not get this last question done, please get it done. Yes, ma'am. You want to give me one more?
Yeah.
Okay.
You could put 7 over 100. Okay. 7 tenths over 100?
Nope.
No.
7 over 100.
Like that?
No. Never mind.
Like that?
Yeah.
Because technically, and this is something you were actually going to be learning starting Friday. That is not a fraction. That is a ratio. No, nowhere on here did we say 7/10 hundredths. Everything is 7/10 to 100. 100 meters to 7/10. For every 7/10, it's 100 meters. So that is how you write a ratio in a fraction form. That is why we can put our decimal in our fraction, because it's not actually a fraction, it's a ratio. All right, please go ahead, get this glued in on this page. Stop talking. I'm going to be coming around with your pull down. Please make sure. Ethan, you put your name on it. Feel free to put the last initial on it. It needs to be turned into the bin when you guys are finished with it. And then you're working on Imagine Map. If you want to move around the room, you may. What's your number? I'm not sure why I hear any conversation.